So hey guys, we are back with another session today, and we have Pranav Prajapati with us. So I'm calling Pranav on the stage. Hey Pranav, how are you doing today?
Hello, Ketan. I am fine. And before this, me and Ketan were trying to set up my whole this research paper, and that's why we got a bit of late. But yeah,
Yes.
Ketan, we are here now.
Pranav will be talking about RAG and MCP today, so I'm handing over the stage to Pranav. All yours.
Yes, thanks, Ketan. So yeah, Ketan left early, but today we are going to see about one of the research papers, which uh, let me see. Which I read few days back in my organization when we were trying to work with MCP and various other tools. So for this paper, there are some prerequisites which I will try to explain as they come in our paper. And along with this, let's directly jump to the paper and see what it is about. So uh, let me see if my screen is visible. Okay, so this is the paper which we are going to discuss today. It's called RAG-MCP, Mitigating Prompt Bloat in LLM Tool Selection via Retrieval-Augmented Generation. So here are two things involved. The first one is, let me change the color. Yes, prompt bloat. So, prompt bloat is a condition where your prompt gets too much large in size, that is 1,000, 2,000 lines of prompt, just 1,000, 2,000 lines of prompt with different information about how the agent needs to respond. So, a prompt can contain uh, response guidelines, it can contain tools, and it can contain some instructions that the agent needs to follow thoroughly. So, in response, we can ask the agent to be like in formal written written response in formal way, or written a markdown format or something like this. So I have an agent which has prompt, and a prompt consists of various components. So the first one is about how the agent should respond. The second one is about tools. So depending on the number of tools the agent has, we put the name of tools and their description inside the prompt. So suppose I have a prompt get I have a tool called get weather that just brings the current weather to my agent. So whenever my agent will call this tool called get weather, it will bring the current weather to my agent. And this get weather tool is a function, so it will have some parameters. It can be city. So tell get weather what it needs, that is city, and get weather will return you a dictionary of current weather of that city. Fine. So what goes inside my prompt is name of this tool. So name of tool, that is get weather, this one, and the description of this uh, tool. So what is the description? The description is a short way of saying that what this tool does, and it also says that parameters, and parameters will be ct, which should be a string, and what it returns is a dictionary. So what happens is this whole information which we are seeing here gets put inside this prompt for my agent. And the last thing is instruction is just giving it some kind of personality, that you are an expert agent specialized in this task, so this can be instruction. Now What's happening here is we just, if you see, if I have just one tool, it comes with this amount of context, that is the name of the tool, the description of the tool, and what parameter it takes and what it returns. So these are 4 or 5 things that get inserted inside my prompt, right? So when number of tools keep on increasing, that is one tool, 5 tools, 6 tools, 7 tools, 8 tools, such information about each tool keeps appending inside my prompt, and it causes the condition called prompt bloat. So what happens here is the response time changes. Now my agent will take too much time to respond cause the prompt is already too much, and cost will increase cause every time I send the API this many number of tokens, my cost is going to increase. So what this paper discusses is how we can mitigate this problem of prompt bloat in LLMs via tool selection and RAG. Now, how many of you know about RAG? Let me see if there are some. Okay, we have someone from TFUG. Hello, Vedansh. And yeah, many people over here. And today we are here to see about a research paper. Um, okay, I think we can talk a bit about RAG. So let me go to some new paper, new page or something. What's this? Okay, fine. So let's understand RAG first. So RAG, it stands for retrieval retrieval augmented generation. I'm getting calls from my um workspace. So RAG is retrieval augmented generation, and it contains of 3 components. The one is retriever, which retriever, not retriever we can say, but a vector database, a embedding model, and a LLM model. So what happens with RAG is I have a PDF or Word document, and I have a PDF and Word document, and what happens here is uh, I take this PDF and Word document inside a vector database using some embedding model. So we have an embedding model in place which tokenizes this whole PDF and puts it inside a vector database. So the task of this vector database is to store token embeddings, fine, of this whole PDF. Now a user will come and ask something related to this PDF, that uh, what is RAG. Suppose this PDF is related to RAG, and then what will happen is the same embedding model with which we stored everything inside this vector database will will be used, and we will get some tokens. Fine. Now I will match these tokens with this vector database using cosine similarity. So what will happen is, as I have this question, and I have this vector database which will have chunks of information, and top 10 chunks which will match to the embedding token inside this vector database using cosine similarity will be returned to me. So the top 10 chunks will always contain information about RAG, because the PDF talks about RAG. Fine. So my 10 chunks will contain information about RAG. Okay, so this is how RAG works. That is, you have some text of information, which you put inside vector database. Then whenever a user query arrives, you do embedding of that query and get tokens, and you match that tokens with your vector database. Then you get some chunks, and these chunks you can pass it to your LLM inside prompt. So inside prompt you can pass these chunks as information that you need to answer from these chunks, because these chunks are corresponding to this PDF, and PDF is my source of truth. So you guys might have seen that whenever we append some file or ingest some file on chat gpt, behind the scenes this is something that happens. They use in memory vector database, but there are a couple of vector database in the industry like V8, uh, then Quadrant and Milvus. So the work of vector DBs is to store vector information, that is token, the numbers of tokens, and uh, just store them and do cosine similarity and bring up the top 10 matching chunks related to user query. Now let's get to our paper, and it's published by this respected authors and comes from Beijing University of Post and Communications. So abstract for this paper is large language models struggle to effectively utilize a growing number of external tools. So as I said that growing number of tools increase prompt load. So what happens is when my number of tools keep increasing, prompt bloat starts to happen, that my size of the prompt starts increasing. So let me just put it over here that prompt bloat means big big mm, big or big and too much lines of prompt, too much lines of prompt. Fine. So whenever MCP tools or some function tools are introduced, the size of prompts keep on increasing. And what this paper does is it proposes an architecture called RAG-MCP, where you cut down the prompt by 50%. So what it's saying is, we will try to understand, but you cut down the prompt by 50% and you can increase the number of tools. So it's saying that at one time my size of prompt will decrease, but I can increase the number of tools. So let's see how these guys are trying to achieve this. So, what happened traditionally is that each and every tool which I had access to the agent were appended inside the prompt. Fine. So, all this information about that tool was appended inside the prompt. Now, according to this paper, you will get to increase the number of tools and decrease the number of prompts. So let's see how these guys are doing it. So, large language LLMs have demonstrated remarkable capabilities in natural dialogue, reasoning, and even code generation. However, they remain fundamentally constrained by knowledge encoded in their parameters and fixed context available at inference time. So, in essence, an LLM with external access is trapped with only training data and cannot easily be updated with its knowledge or perform actions in the world. To address this limitation, recent efforts have focused on augmenting LLMs with external tools and tool calling. Fine, function calling. So these are some kind of tools that will bring latest information to my agent. So, by invoking tools using web search, databases, calculators, and defined functions or APIs, LLMs can fetch up to date information and execute complex operation behind its report, repertoire. I'm not sure what this word is. Let's just mark this for now. Let me see. Rep. What's the meaning of this word? Stock of place, dance, or items. Not sure. Okay, new word to my dictionary. So it's just saying that how with tools and functions we can bring up to date information to LLMs. Moving forward, in research community, a variety of approaches have been proposed. Prompt-based strategies like React, which is a very well-known strategy. It stands for reasoning and action. Fine, and it's just like how you create prompts that allows LLM. Wait. That allows LLM to decide when to consult a tool in context of multi-turn process. Now, what is a multi-turn process? Multi-turn process is like I have this LLM over here, and it will be it will first find some information, like it will call some tool, it will see what this tool has written, go back to LLM that hey, this tool has written this, and then again see that if we can call some new tool or we can directly go to our output. So that's basically multi-turn LLM call. So if I just say hi, it will just be completed in one turn from the LLM, that is hello, I am ChatGPT or something like this. But if I ask it a complex query that find me top 10 flights to Mexico, then what it will do is it will go through multiple turns. First, it will find the flights, then it will try to find top 10 flights for me. So that is a multi turn setup. Fine. So then they talk about tool formers and things that are used to fine tune LLM and all this information about it. So, moving forward, they talk about prompt bloat is a critical issue. Providing the definitions or usage structures in every possible tool in model context will consume an enormous number of tokens and risk overwhelming the model. So if you give it so much kind of information, it will of course start hallucinating as well. So it has been observed that it is effectively impossible to describe large collection of APIs or tools in a single prompt. So as I explained that if you have a large collection of tools, you cannot put them all in one prompt. It will cause prompt bloat. Fine. So what this uh, research paper talks about is this new architecture. So this is the traditional one, and this is what it paper talks about, that is RAG-MCP, this thing over here. So what we do is in traditional methods we had MCP, uh, the user's prompt and everything related to that tool, that is description, name and parameters, and what that tool returns was put inside the prompt and sent to LLM to query, and then the tool will return some result, and finally the LLM will give its final response. But in this setup, we have prompt, we have query, we have a tool which is RAG-MCP. Now, let's see what they are saying with this diagram. In this diagram, to tackle these challenges, we propose RAG-MCP, a solution that uh, a solution that what marries retrieval augmented generation with model context protocol framework. So what they are proposing is that we have uh, MCP tools and we will also use RAG on them. Now let's see how they will do this thing to increase decrease the size of your prompt and increase the number of tools as well. So uh, in our approach, the numerous available tools description, MCP functions, schemas, usage examples are stored in an external memory indexed by their semantics. Whenever a new query arrives, a dedicated retriever vector space semantic search first selects the top k candidate tools that are most likely to be useful for that query. Only those k tools descriptions are then injected into LLM's prompt or provided via function calling API, greatly reducing context length and complexity. This whole line was explanatory that what this paper is trying to do. So let me open new page and try to explain what's happening here. So they are saying that you bring n amount of tools or APIs or functions, fine, and all this will have their name, their description, the parameters they take, and the last thing is what they return. Fine. So these tools are put inside the vector database along with their name, description, parameter, and what they return. So this vector database contains all this information in vector form. Now, whenever a user query arrives, I will do retrieval augmented generation, that is RAG, on this set of information. And the top K tools that will match the user query and the description, param, return, or name of the tool will be returned via my vector database. Now here we will of course do cosine similarity, that is the user query and the tokens of user query, or you can say embeddings, and the embeddings of this all stuff, and then we will get some top 10 tools suppose, and we will just put this top 10 tools inside the prompt. So now you see that my prompt doesn't need to have tools or functions prior hand. What's happening here is based on user's query. So if user asks about, hey, uh, order me food from Zomato, then what will happen is we will do RAG in this vector database, and all the tools or APIs that are related to Zomato will pop up due to similarity, and this top 10 tools will go inside my prompt. Now my prompt knows what tools are there, and it will just call those specific tools. uh, that is my LLM will now just call those specific tools. So makes sense that what we are trying to do here. So let's get back to our research paper. So that's all this research paper talks about, that this is what they do and what were the observations. So in summary, this paper tells that they propose a new framework which is RAG-MCP, and this is a scalable tool retrieval technique. Of course, you don't need to put all your tools once inside the prompt, but they need to be inside a vector database, and we retrieve only those which are related to my user query. So the LLM will only call useful tools, reducing the prompt size and increasing the set of tools you have, because in database you can put like thousand number of tools and their description, their name, and their parameters. And this improves tool use performance, because only the tools which are effective will come inside the prompt, and the LLM will call those tools only. So related work to this paper is tool use in LLMs, and of course the RAG paper, model context protocol from Anthropic, and finally the methodology of this paper. Now here are some benchmarks, like they did some stress testing and what they found. So to overcome prompt bloat, RAG-MCP applies retrieval-augmented generation RAG principles to tool selection. Instead of flooding the LLM with all MCP descriptions, we maintain an external vector index of all available MCP metadata at query time. So what happens is uh, reduce prompt size. Of course your prompt size is going to reduce if you don't put tools description in that. Then lower cognitive load, that is, the LLM no longer needs to sift through hundreds of distractors, because each tool will come with like a specific description, and they can vary in fields. So a Zomato tool can be different from some uh, a tool of Zomato can be different from YouTube tools. That is, YouTube tools can be search video, get transcript. So this is a different set of topic, and ordering fruit from Zomato tools are a different set of topic. Fine. So if we start putting all these tools description in one prompt, of course the LLM is going to get distracted. So that's why they are proposing that we put all the tools inside vector database and do RAG on that, and improve resource efficiency, because you don't need to send like a big prompts to the LLM provider, and your cost will reduce per token. And multi-turn robustness. And what is multi-turn? That with every turn you can retrieve new set of tools, and always be up to date. Now this is the three stem pipeline which they did. That is, they did query encoding with Quen model, and they put all this inside vector database, and then they get the top 10 or top k tools or MCPs, which they put inside the LLM function or LLM prompt. Fine. So discussion is our methodology combines the rigor of stress testing with effectiveness of retrieval augmented tool use. The stress test quantifies a sharp performance drop that occurs when MCPs swell the prompt, mirroring long context recall failures in NIH evaluations. So NIH is a kind of evaluation which they do for LLMs. Let's see. I think this refers to one of the papers. Yeah, um, needle in a haystack. So, like you have a big number of tool sets, and you need to find that one tool which is going to help you order food from Zomato. So that's NIH evaluations. And then they did some experiments, and this is the heat map of that experiment. And finally, this is like what setup they did for RAG-MCP. They seem to be using DeepSeek as their evaluator. So basically what DeepSeek is going to see, that do we call or get the right number of tools when trying to do RAG with the description of those tools. And then they have some baselines for evaluation, that is blank conditioning. Prompt the LLM with all NMCP descriptions at once and ask it to choose the correct one. An actual match, pre-filter the candidate pool using simple keyword matching on the task description and MCP metadata, then prompt the model on this reduced set. And then finally, this is RAG-MCP, which does vector index retrieving and get the top n MCPs and inject them inside the prompt, LLM prompt. And we evaluate performance using three key metrics for each baseline method, that is accuracy, average prompt tokens, and average completion tokens. And with blank you can see that accuracy is just 13%, because finding a needle in haystack, this is the case that it has so many tools, and it is like just 13% of times it is able to find the right set of tools. Then what is actual match? Actual match is like they are trying to see most number of matching words in user query and the description, and there they just get 18% accuracy. But when they are retrieving some tools from the vector database, they get 43% accuracy in selection of correct tool. And that's this paper about. We will directly jump to conclusion. I don't think uh, you guys can go and read it on your own, because if I just sit and explain this whole paper. It will take a lot of time, but this was like all the basic idea behind this paper and the architecture these guys are proposing. We present RAG-MCP, a simple yet powerful framework that tames MCP tool sets by retrieving only the most relevant schema for each query with focused retrieval, that is RAG-MCP. This drastically reduces prompt, boosts selection accuracy, and maintains extensibility. And these are the references which they took for this paper. And yeah, that's all. That's the topic for today. And let me come back to my screen. So I think uh, that's all, and I'll end the stream. If you guys have any questions, you can ask. I'll wait for here for like few minutes. I have Anup saying yo. Hi Anup, Vedant, hello, hello Sai. So yeah, seems like uh, you guys got to learn new things with this, and yes, let's end up the stream. Thank you.